Pythagoras theorem is what we're looking at in this video. So it's split into 4 parts. First, we're going to start off by looking at examples like this one here, where we've been asked to find just a missing side. And then we're going to look at how we can use Pythagoras to find the missing side so we can find the area of a triangle. And then we're going to move on to more problem-solving questions like this. And then finally, we're going to look at questions finding the distance between coordinates using Pythagoras. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause, and I've got the example on the right, which is you do. So here we've been asked to find the missing side to one decimal place. Now, using Pythagoras' theorem, because this is the longest side, how do we know it's the longest side? It's opposite the right angle, okay? If the side is opposite the right angle, it's the longest side. Now, to find the longest side, we can use the formula, which is the sum of the other two sides squared. So all I've done here is I found the square root. I've wrote the square root of this squared plus this squared, and that is my answer. So if I now type that into my calculator, I can do 8 squared plus 3 squared, and I get an answer of 8.5 centimeters to 2 decimal places. Sorry, to 1 decimal place. Now, hopefully you've pressed pause and I've got the example on the right. So again, here, you're finding the longest side. So to find the longest side, you put a square root in, and then you square the other two sides and add them together. And if I type that in, so that'll be 2.5 squared plus 10.5 squared. That gives me 10.8 centimeters. Now, looking at this example, now here, it's not the longest side, because remember, the longest side is opposite the right angle. So this is one of the shorter sides. Now, to find one of the shorter sides, it's very similar. Instead, we just have a negative in the middle. And just be careful here. You want to put the big number to the left. So it'll be 8 squared minus 6 squared. So you're still squaring the other two sides, but this time we're subtracting. So this time, I type that into my calculator with the subtract because we're finding one of the shorter sides. So yeah, hopefully you've pressed pause and I've got an example on the right. So again, it's asking for one of the shorter sides, which means we're going to subtract and always put the bigger number to the left. And if I just type that into my calculator, and that is essentially how we use Pythagoras' theorem to find the missing side of a right angle. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. So moving on, here we have got a right angle. And that is also key worth being mentioning. This only works with a right angle triangle, the Pythagoras theorem. So it's asking us to find the area of the triangle. Now remember, the formula for the area of a triangle is the base times the vertical height divided by 2. So we need the vertical height, which is that height there. So if I just call that x. Now to find x using the Pythagoras theorem, because it's one of the shorter sides, remember that's the longer side, yeah? Opposite the right angle. We're going to add a subtract there, and we're going to put the big number on this side, small number on this side. And if I type that into my calculator, we'll leave it as a root for now, because we don't want to sort of put all the decimals in yet. So now we know what that is, we can use the formula for a triangle. So that's base, which is 5, times the height, which we found as root 119, divide that by 2. So if I type that into my calculator, I get 5 times root 119, divide that by 2. So the area of this triangle is 27.3 centimeters squared. So hopefully you've pressed pause and had a correct example on the right. So again, to find the area of a triangle, it's base times the vertical height divided by 2. This time we do have the vertical height, but what you don't have is the base, or the width, whatever you want to call it. So we can just call the missing side x again. And x is one of the shorter sides because the longer side is opposite the right angle. So if you use Pythagoras, because it's one of the shorter sides, we're going to subtract. So it'll be the big number, take away the small number. And if I type that into my calculator, that'll be 14 squared minus 9 squared, which becomes root of 115. And for the area then, that's just going to be the base, which root 115 times height, which is 9. Divide that by 2. And again, if I type that in, I get an answer of 48.3 centimeters squared. Now, moving on. So here we've been asked to find the length of BD. So if I join the 2 points together, B and D, it's a diagonal. And I can call this X. So again, you can think of this as a right angle triangle there, right? You know this is 6, and you know this is going to be 10 because it's going to be the same as what that is. So if this is 10, this is 6, this is opposite the right angle, that's the longest side. Okay, so if it's the longest side, remember, inside the square root, we're going to add a plus sign, and we're just going to square the other two sides. So my answer here is going to be 11.7 centimeters to 1 decimal place. So hopefully you've pressed pause and had a go at this. So firstly, where is AC? AC is there. The right angle is there. So it's asking for the longest side. So again, X is going to be the square root with a plus. and square the other two sides. And that gives me 20.9 centimeters as my answer. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. And moving on, so we're now looking at more problem-solving questions. So we have a square inside a circle. Find the area of the circle. Now, to find the area of a circle, we have a formula. Area is pi r squared. So I'd either need the radius or the diameter. So if I connect two of these sides together, if I can find that length is the diameter. And if I have the diameter, I have the radius. So what I need to find is this value here. And because I know it's a square, I know that this side here is also going to be 5 centimeters. And again, hopefully you can see that this is your right angle there. And you can use Pythagoras' theorem now because it's a right angle. We know the other two sides. We're looking for the longest side. So that's going to be x. It's going to be the square root with a plus of the other two sides. And that gives us, again, we'll leave it in the third form because we want to keep the accuracy. So that's the diameter. Now the radius is just going to be half of that. So the radius is just going to be 5 root 2 over 2. So that means the area of this circle is going to be pi r squared. So if I just do pi times that all squared, I get an answer of 39.3 centimeters squared. So again, hopefully you press pause and I've got the example on the right. So it's asking for the area of the circle. Area of a circle is pi r squared. And we can use one of the diagonals. Once I have that, that's the diameter, we can just half it. So that's your right angle there. So what we want is this side here. So it's the longest side. So x is going to be the other two sides squared and added together. So that's going to be that. So we can leave that, as I said, for now to keep the accuracy. So that's the radius. That's the diameter, sorry. So to get the radius, it's just going to be half of that. And then if you get the area, that's just going to be pi times r squared. And that is going to be pi times that divided by 2 all squared. And that gives us 85.6 centimeters squared to one decimal place. So moving on. So here we've been asked to find the missing side x, and we have two right angles. So now to find this side, I can square this and this because it's the longest side, but I don't quite know what this is. So the first thing I need to do is find what this is. So I have to use the Pythagoras theorem twice in this question, because first I need to find this side. Once I know what this side is, I can then use it to find x. So now to find this missing side, let's just call this missing side y. Now y, if you look in this part of the triangle, is one of the shorter sides. So that means y is going to be the square root with the subtract in the middle, big number on the left, small number on the right. So that is going to be my value for y. So which is 8 root 2, and we'll keep that for accuracy. So now I know what y is, I can now look at this triangle here. This is a right angle. We want to find x. X is the longer side. So x is going to be the square root with a plus in the middle. So that's going to be 6 squared plus y squared. And we know what y is. So that's going to be all of that squared. So if I now type that into my calculator, so that would be root 6 squared plus that squared. And that gives me an answer to one decimal place of 12.8 centimeters. So hopefully you've pressed pause and I've got an example on the right. So again, here we've got two right angles. We want to find this side, and then we can use Pythagoras to find the other one. So if you focus on this triangle here, we want to find, let's just call that y again. So y is one of the shorter sides. So that means the square root is going to have a negative in the middle. Big number, take away the small number squared. And that gives me 6 squared minus 4 squared, which becomes 2 root 5. And then to find x, now x is, again, one of the shorter sides in this case. So because x is one of the shorter sides, you put a subtract in the middle. So that would be the big number, which is 12. Take away 2 root 5. 2 root 5 becomes 4.74. So that's how I know it's the shorter one. So that would be that squared. Take away 2 root 5 squared. And then if I just do 12 squared minus that squared, that gives me an answer of 11.1 centimeters to one decimal place. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. And now moving on. So we've been asked here to find the distance between 2 points. So if I plot these 2 points, point A is minus 2, 3, and point D is 2, 0. So now that I've plotted these 2 points, it's basically asking me to find the length of that blue line. And the way I can do that is I can just create a triangle with these red lines. And I know the height here is 3. I know the width here is 5. And let's just call this side X. So now hopefully you can see we've got a right angle triangle. It's asking us to find the longest length. So we're going to add a plus in the middle. So that's just going to be the other 2 sides squared. And if I do that on my calculator, that'll be 3 squared plus 5 squared. And to 1 decimal place, that becomes 5.8 centimeters. And again, on the right, so we have minus 3, 3. So that's going to be there. We have 2 minus 1. That's going to be there. Connect the 2 together. And then if I use a red line here and here. So the height here is 4. The height here is, the width here is 5. And again, like I said, that's a right angle. So we can just call this side X. And it's the longest side. So inside the square root, I have a plus in the middle. Square the other 2 sides. And my answer becomes 5 squared plus 4 squared, which is 6.4 centimeters to 1 decimal place. Oh, and so sometimes it can be given without a graph, and you can sketch out a little graph. So if I look at these 2 points, I would say if we have 2, 1 here, and this other point is 5 on the x coordinate, so it's going to be further along this way because it's 5, and it's going to be higher up because it's a 9 on the y, so it's going to be somewhere there. So we can just say this is 5, 9. And then again, if I connect these 2 together, and now it's just a case of finding, well, actually, what's this and what's this? So going across, we are going from 2 to 5. To go from 2 to 5, that means we're going 3 across. So I can write that in here. So we're going 3 across. And in terms of how high up we're going, we are going from 1 to 9. So to go from 1 to 9, that means we're going up by 8. So that is going to be 8. That's your right angle there. We can call this side X. So we're looking for the longest side, which is X. So that means a plus in the middle, square the other 2 sides. And if I do that, that'll be 8 squared plus 3 squared, which gives me, to 1 decimal place, 8.5 centimeters. Now, hopefully you've pressed pause again and had a go at this. If I visualize this, minus 3, 2, let's just say that's there. Now, on the X, I can see it's going to be going across because that's 4. And on the Y, it's going to be going up because that's a 5 and that was a 2. So it'll be somewhere there again. So let's just drop that there. That's your 4, 5. Connect the 2 lines together. And then if I just draw my little triangle. So we are going up across from minus 3 to 4. So we're going across by 7. They're going up by 1 from, not 1, sorry. They're going up by 3 from 2 to 5. And we can just call the missing side X again. And then that is just going to be them 2 added together because we're looking for the longest side. So that is just going to be root 7 squared plus 3 squared. And that gives me 7.6 to 1 decimal place. So here's the practice questions. Press pause now and have a go. Here are the answers. Mark your work. Now, if you would like some more practice on this, I've got a full worksheet linked down in the comments below. And if you found this video useful, I've got loads of other content like this.